Hi, Peter here from True North Marine. Today we have a great video for you. I call this the nuts and bolts of coastal navigation. In this video we're basically going to cover everything that is required for undertaking a passage from position A to position B. Now this will include plotting courses, taking bearings, fixing our position, converting variation and deviation, and a lot more. Before we start, I just want to tell you about our marine radio license course. If you have a marine radio on board your vessel, you do need to have a license for the radio. More importantly, if you're purchasing or you have a DSC radio on board your vessel, you'll need a radio license to obtain your Maritime Mobile Service Identity number. So don't leave that to the last minute, because the government office that issues the licenses can take up to 15 days to process a license application, which is displayed on their website. So if you need your license, just go to our webpage at truenorthmarine.com.au and we can organise that very quickly for you to get that process up and running. Okay, let's get started with today's coastal navigation video.
Let's say we're just south of Roserick Shoal and we'd like to sail to the jetty at South Mole Island. If you lay your parallel rules between these 2 points, you'll discover immediately that you can't get there direct. We can't sail between North Mole Island and Mid Mole Island. The chart says it's an unsafe passage. Also, it's a bit dicey between South Mole Island and Mid Mole Island. So, we're not in any hurry. Let's take the prudent way and sail north of Hannah Point, on North Mole Island, to a point about due north of South Mole Island Jetty. Then, turning to starboard, a course of 180 would bring you pretty well straight onto the jetty. Our first leg takes us from Roserick Shoal, 20 degrees 11 minutes south, 148 degrees 42.5 east, to pass just north of North Mole Island. Lay the parallel rules with the bottom edge between these 2 points and draw a pencil line. Don't worry if you extend the line too far. This is called your run line, the basic course you intend to sail, otherwise known as your track. Hold the bottom section of your parallel rules firmly and move the top part up gently until the top edge is exactly over the dot in the centre of the compass rose. Now, remember which way you're sailing, sort of south of east, yes? Therefore, the direction is the same from that dot in the centre of the compass rose to the outside ring. Read the number of degrees where the parallel rules cut the ring. 106 degrees, right? So we know then that our true course to the first waypoint, or turning point, is 106 degrees. We need to convert this to a compass course, in other words, the course we must steer. Remember the letters? T, V, M, D, C. T, 106, true course. Variation, 8 degrees east. Compass to true, add east, so we must subtract, which makes the magnetic 098. Deviation, 7 degrees west. We had to subtract east, so we obviously add west. So the compass course is 105 degrees. I can hear you saying, what's the point of going to all that trouble, just for 1 or 2 degrees? Well, 2 reasons. 1, it doesn't always work out that close, and 2, 1 degree can make the difference between hitting a large rock or passing it safely. So we can turtle off then with the compass point into 105, which means we must pass over the turning point, right? How do we know when we're at that turning point? We use what is called dead reckoning, which is really dead reckoning, D-E-D, dead being short for deduced. By using time, speed and distance, we can deduce that we'll be at a certain place at a certain time. Here's how it works. Let's say we left Roserick Shoal at 1000 hours and set our speed at 5 knots. You don't have to be a genius to work out that at 1100 hours we should be 5 miles along our run line. Put 5 miles on your dividers. Remember to use the latitude scale at the side of the chart. Then place one leg of the dividers on our departure point, and where the other leg cuts through the track, the run line, make a cut with a pencil. That cut marks your DR position for 1100 hours. Now, write the course, true, at the start of the line and the time of departure above or below the line. Then write the time at the DR position. There are 3 symbols for marking positions on a chart. You've already done one of them. You mark that DR position by a simple cut through the track. That designates just that. A DR position, a position which considers only time, speed and distance. Next is the estimated position, the EP. This is a position which takes into account time, speed and distance, plus an allowance for tidal movements and leeway, etc. It's always marked with a triangle around the dot, marking the exact position. The third symbol is the observed position, the OP, one that is a definite fix, by taking 2 or more bearings on known objects. It's marked on the chart with a circle around the position. Back to our course then. Measure the distance from our departure point to our turn point. You should find it 7.3 miles. Will take us 1 hour and 28 minutes. So, at 11:28 hours, we'll be exactly over our turn point. Or will we? We can't rely on this completely. It's just a DR, deduced position. Many things could influence that, such as winds, currents. We need to check our position accurately. How? By taking 2 or more bearings of known objects to get a fix, an observed position. From our boat, we should be able to see the southeast corner of North Mole Island. If we take our hand-bearing compass and use it in a position on the boat where it will not be influenced by metallic objects, in other words, there will be no deviation, we point the compass at the southeast corner of North Mole Island and find that it reads 211 degrees. As I said, there is no, or shouldn't be, any deviation on a hand-bearing compass. We get a direct magnetic bearing. We still need to apply variation, which we know is 8 degrees east, and because we're converting from compass to true, we add east. It gives us a true bearing of 219 degrees. Now we must plot that on the chart. Place the top edge of the rules to cut both the outer ring at 219 and the dot in the centre of the compass rose. Hold the top part of the rules firmly and gently move the bottom part down until the bottom edge just touches the southeast corner of North Mole Island, the same place that we sighted with the hand-bearing compass. Now, draw a pencil line from North Mole Island in the direction of our boat, long enough to pass the spot where we think we might be, and draw an arrow at the seaward end of this line, so we can see at a glance where the bearing originated. This line is called a position line, and we know that we must be somewhere on that line. The question is where? To find that, we need a second position line. When using a chart, always remember where you are in relation to the object on which you're taking a bearing. Ideally, we need some object at around 90 degrees from our first position line. The wider the angle, the more accurate our fix. We could take a bearing on Mount Chain, but the cut would be too narrow to be very accurate. Look ahead and you can see Sid Island. Take your hand-bearing compass and get a bearing of the north end of the island. Let's say it reads 107. Add variation, 8 degrees, so Sid Island bears 115 degrees true from us. Using your parallel rules, lay one edge on the centre dot and 115 degrees. Then move the bottom part down so that it touches the north end of Sid Island. Draw a line to cut our first position line. Draw an arrow at the seaward end of this line. Where those two lines cross is exactly where we are. Think about it. We know we were somewhere on that first position line. We also know that we're somewhere on that second position line. So the only place we can be is where they cross, a little further east than we thought. The actual position at 11:28 is 20 degrees, 13.45 minutes south, 148 degrees, 50.71 minutes east. Because it's an observed position, we can now draw a circle around a fix and write the time we took the bearing. This observed position using 2 bearings is accurate enough for most situations. But if we wanted to be really accurate, we would take a 3rd bearing. We need somewhere that's about halfway between our other 2 position lines. And, looking to port, we can see the really high part at the north end of Whitsunday Island. Looking at the chart, we can see that this coincides with Whitsunday Cairn, 380 metres. Perfect. Out with the HB compass, and it reads 057. With variation added, that's 065. Plot this line just as you did before, and the result probably gives you a small triangle at the intersection of the 3 lines. This is called a cocked hat, and is a very reliable fix. We have to be somewhere within that triangle. If your triangle is too large, more than say a mile, you should take the bearings again. Notice that I've placed the dot signifying our position towards one end of the triangle. Always assume your position within the triangle is in the direction of the nearest danger, the shore on North Mole Island in this case. So, now that we know exactly where we are, we can lay a course for the jetty. Take your parallel rules and lay them on the chart so the left-hand edge touches both the jetty and our observed position. Hold the right-hand side and move the other across to the dot in the centre of the compass rose and read where it cuts the outer ring, 190 degrees. So the course true to the jetty is 190. We need to convert this to a compass course just as we did before. So write the letters. T, 190 degrees. Variation, 8 degrees east, subtract. Magnetic then, 182 degrees. The deviation, 3 degrees east, subtract. So the compass course is 179 degrees. If we steer so our compass reads 179, then we should arrive right at the jetty. If we measure the distance from our 11:28 hours OP to the jetty, we find that it's close to 2.3 miles. So if we're still doing 5 knots, our ETA, estimated time of arrival, at South Mole Jetty is 11:58 hours. 1 mile will take us 12 minutes at 5 knots.